Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of using the Pythagorean Theorem. This is standard 8.7c in the great state of Texas, and we're using item number 23 of the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. Alright, so we have a rectangle. They're calling it a parallelogram, but that's fine. PQRT. And we need to prove that it's a rectangle. It visually looks like a rectangle, but what they're giving us is that it's a parallelogram. Okay, so what do we know about a parallelogram? Now we got to go all the way back to our definitions of geometric terms. Okay, so a parallelogram, right, is a four-sided shape. And it's got two sets of parallel lines. I'll use the abbreviation or the visual representation of the term parallel in geometry. Two sets of parallel lines, right? And it looks pretty obvious. The top and the bottom set are parallel. The two sides are parallel. Now, what is it that makes a rectangle a rectangle? Well, first off, all rectangles are parallelograms. Right, so if we're looking at, our subsets, right, we've got quadrilaterals, right, and then inside the quadrilaterals we've got the parallelogram, because a quadrilateral is just a, four-sided shape. And then inside that parallelogram we've got a few things, but one of the things we'll be looking at is a rectangle, right? So what makes a rectangle a rectangle? Well, it is a parallelogram, but it also has four right angles, or four 90-degree angles. So that's what we need to prove. That's the difference, right, is that parallelogram has four 90-degree angles, because you can also have a parallelogram like this. Kind of looks like a diamond, but it's not really a diamond. It doesn't have four 90-degree angles, but it does have, two sets of parallel lines. So what makes this parallelogram a rectangle? Well, it's got these four right angles. So we think these four are right angles. How do we prove that? Well, it would be easy if we had a protractor, but we're not supposed to use that here. Hopefully we notice, what? We've got this dashed line right here. And if I draw it like this, now what does that look like? Oh, that looks like a right angle. And that right angle, if I draw that dashed line, turns that parallelogram into two different right triangles. Okay, so what do we know about right triangles? Well, we know that right triangles, I'll open up my reference chart here. We do a lot of right triangles here. It's down at the very bottom, that additional information, a squared plus b squared equals c squared. That's the Pythagorean Theorem. It doesn't necessarily say right triangle, but that's what we do in 8th grade, is we mess around with the Pythagorean Theorem. And so what that means is a squared plus b squared equals c squared, right? These are the two legs of the right triangle, and this c squared is your hypotenuse. All right, so if we can show that here's my hypotenuse right here, so that's my c. So let's make that the a and that the b. If I can show you that a squared plus b squared equals c squared, I can prove that it's a right triangle. And if I can prove that it's a right triangle, then I can show you, right, that it's a 90-degree angle. That will prove that it's a rectangle. All right, so let's just look at how they set some of these up. See if any of these show me a squared plus b squared equals c squared, depending on the right angle they have. So I've got 15 squared minus, okay, a is not going to work because it's a squared plus b squared. So let's go ahead and get rid of that. 8 plus 15 equals TQ. TQ is this hypotenuse right here. That's great, but it needs to be squared. So that's not going to work. 15 minus, first off, they're not squared. Secondly, we don't subtract. Okay? We add. There we go. 8 squared, that's a squared, plus b squared, that's 15 squared, equals c squared. That's my TQ squared, my hypotenuse. That's my answer, D.